Hello, in this video we're going to use application Flowy14 to calculate the area under the function f(x) equals x to the second power, and that's on the interval from 0 to 1 with a stride or step of 0.05. Let's proceed to our Flowy14 application. Into our dashboard here, we'll proceed to add and design our flow. We need to add commands. So to open up the command menu, proceed to the upper left corner where it says commands, click into it. This in turn opens up the left-hand side command menu. You can navigate to each command manually, or you can use the search option. So anytime to begin designing our flow into the dashboard, the first command to add will always be the start command. And for today's exercise purposes, we'll need to add the for loop with stride command. So just type FOR4. And you can see we have two different types of for loop commands, so you can choose the appropriate one that you need. Today we'll need the for loop with stride, and each command has a short description of it right beneath the command. So we'll need the for loop with stride. And then because we are using the calculating the interval from 0 to 1, we'll add through the inbound data connectors that are highlighted in blue with numeric paths. We'll add 0 and 1. So adding 0, that's our interval, and then clicking again into the command and into the second inbound data connector with the numeric path in green, adding 1. So this is our interval 0 to 1 and with a stride of 0.05. So click once again into the command and add through the inbound data connector with the numeric path 0.05. That's our step or stride, if you will. 0.5 and enter. Okay, so next we'll need 3 mathematical commands to fulfill our algorithm for the purposes of calculating the area. So let's just type the word math. And by default it comes with the plus sign addition. No worries, we can, as long as we have the command placed in our dashboard, highlighted, and you can turn it into any of the down below options. So in this case we'll need multiplication, as we need to multiply f times x, and then we'll need a second multiplication command because we need to calculate the x to the second power, and then we need to multiply that result by the stride 0.05. So add another mathematical command and turn it as well to multiplication. So you can see that both plus signs have turned into multiplication signs, and then we'll just need to add the results. So let's add another mathematical command, and this time we'll just retain it as is with the plus sign. And so we're calculating here our area under the function fx times equals x to the second power with the stride for the interval of 0 through 1 with the stride of 0.05. So this is where we will obtain our result, and we'll print it via the corresponding output command. So to add it, just type output. So once you're satisfied with the design of your flow, you can close it off by adding the end command. Just type the word end. So I have a couple of numbers here to add before we start connecting our commands. So on the second multiplication command, I'll click into it and into the first available inbound data connector highlighted in blue, indicating that it has a numeric path attached to it. So click into it, and this command is multiplying the stride, which in our case is 0.05, by the result by the x to the second power. So we'll need to hard code it 0.05. for today's calculation. And in the third mathematical command, the first inbound data connector in blue will hard code here 0, as this is the interval we're starting from 0 to 1. Enter. Okay, so now we've added our commands. We have hard-coded the necessary digits to fulfill our today's exercise and algorithm, and now we are ready to start connecting our commands. So the result of the for loop we've tried, click into its one and only outbound data connector in green. And in turn you'll see all of the other inbound data connectors highlighted that you can connect it to. We are connecting it twice to both pluses on the first multiplication command because we need to calculate the x to the second power. Okay, and then the result of the second multiplication command, click into its outbound data connector in green and feed it into the second multiplication command, into its second inbound data connector, and then in turn that result we're feeding into our addition command, so into the third mathematical command with the plus sign, and into its second available inbound data connector with the plus sign. So once you click plus, it turns into minus. That means the connection has been made. So next we'll need to connect the result here to the 0 here, just because we are starting from 0 and that's our interval. So let's do that. Let's click into the addition command into its outbound data connector and into its available inbound data connector within the same command. And you can see the yellow arrow indicating that connection has been made, as well as click off of the design to make sure that you've connected your commands correctly. So you can just kind of like trace the yellow arrows. They are indicating how you've connected your commands. And so this is the result where we're calculating our area. And to feed it and have it printed, we'll have it displayed via its corresponding outbound data connector. Through its corresponding output command. So click into the addition command where we have our result calculated, the area, and in green into its one and only outbound data connector, and click into the plus sign, which is the one and only inbound data connector available on the output command to print our result. Okay, so we have designed our flow, have hard-coded the information to carry out our formulas, and connected our commands, and now we are ready to execute the flow by clicking run. So it's calculating the area, again from the interval 0 to 1 with the step by 0.05. So that's the first step. We started from 0. And the next one is 0.1. Zero 0.15, 0.2. So basically adding 0.05 to the next result. We are at 0.5. And we're continuing until 1. So 0.5 plus 0.05, 0.55, 0.6, That's the square root times our step. And we're adding it to the previous result to calculate our area. We are at 0.7. Now it's going to be 0.75. 0.8. 0.85. 0.9. And that's calculated. That brings us to conclusion that we've calculated using application Flowy14 the area under function f times x equals x to the second power for the interval of 0 to 1 with the step or stride of 0.05 and printed the result through the output command. Thank you.